2, 1. All right, so let's go. I was pondering if I should do another video on these trig identities. I know that in grade 11, I think I did a couple, and I was thinking when I was covering these advanced functions for grade 12, what the heck, let's do another one, because in advanced functions what you learn is you learn about the compound trig formulas and then the double angle formulas, and then you can expand it to many others. So there are so many equivalencies with these trig items, as you can see, like in terms of the identities, that I think it's worthwhile just to keep practicing more and more examples. So I'm going to give these examples a shot and solve them, and I hope that you can pause the videos and try them on your own. And I will be heavily using kind of the compound trig formula, so for subtraction and addition of angles, and then also the double angle formulas as well. So I don't know if I'm going to need them or not, but I like to keep them handy for myself. Now, I will be honest with you, I don't necessarily memorize these. Like, it's very difficult to try to keep plugging away and memorizing all of these equivalencies, right? It's super useful, and if I use it on a continuous basis or I'm teaching it, then, it kind of sticks around. But then when I let go of it, I forget again and I have to look it up, and that's okay, right? So I'm going to keep these handy so that we can try to see if we're going to be using any of them in these particular trig identities. So let's do them one by one, and let's see if I can actually show that the left-hand side equals the right-hand side for these. So here's question 1. I'm going to bring it down here, and I'm going to try to see if I can attempt it. Okay, so for this example, so we have sine 2 theta, so we know that's a double angle, is equal to 2 tangent theta plus 1 tangent 2 theta. All right, so what do we do? I'm gonna try the more complicated side typically, and then see if I can reduce it to the left-hand side, and then if it doesn't work, I'll go back. Okay, so I'm gonna try with the right-hand side and see what I can do with this. Okay, so it's sine 2 theta, so I certainly don't want the tangents there. So what am I going to do here? Okay, so I'm going to just say, okay, so 10 theta is basically just sine theta over cos theta. Okay, so I certainly can't have 10 theta, so I'm going to try that first. Okay, 1 plus, now tan squared theta, so this is just nothing else but simply sine squared theta over cos squared theta. And then taking that denominator, right, I can find a common denominator for that. So I can kind of already see here. So this right here, right, so this is equal to cos squared theta plus sine squared theta all over, okay, cos squared theta. Now this right here, this is just equal to 1. That's our old school identity of sine squared plus cos squared is equal to 1. So that should simplify this quite a bit. And then this cos squared theta, because it's in the denominator, it's going to pop up. So it's going to be 2 sine theta cos theta, and then cos squared theta, because it comes back there. So that means it will cancel one of these. So that's going to be gone, and this is going to be 2. Okay, there we have it. And that's our double angle, right? So that is actually equal to sine 2 theta. Sine 2 theta. So that's just our double angle. This is right here. All right. And we've certainly derived that in the past from our compound trig identities. Okay, so that's the first one. Okay, so left-hand side equals right-hand side. All right, so it wasn't terrible. I guess I locked out a little bit. Okay, let's try the second one. So here's another example. And by the way, I just kind of randomly, searched out these and just plugged them in here. And then we'll see if I can solve them. So here's the second one. That's the second example right here. This one hopefully is not bad. Okay, well, anytime I have something like this where, you know, they're giving me two things here. So it's the addition of two basically angles, although that x, we don't know what that is. I mean, I can use, so right away, you know, from right here, I can expand and then just use simply, you know, this right here. Cos angle 1 plus angle 2, right? So I can do that and see what that gives me. So that's going to be cos of pi over 2 times cos of x minus sine of pi over 2 cos of, sine of x. All right, so that's just coming in from that compound formula. Okay, now I know what this is, right? Cos of pi over 2 is 0. So 0 times cos x is going to be just 0. So this is 0. Sine of pi over 2 is 1. So this is going to be 1. So minus 1 times that, which is going to be sine x, which is actually negative sine x. Okay, so that's again, so left-hand side equals right-hand side. So we've proved that. Okay, so that wasn't bad again. Okay, so that's all right. So that's number 2. Well, let's keep chugging along here. Number 3. Okay, so try this one. Copy. Okay, paste it back. Okay, let's see. Now this one. Well, I mean, here starting, to be honest with you, I don't know which one's better. Right side or left side. They're both kind of ugly. Okay, well, I mean, let's try. I mean, let's try the right-hand side maybe again. Okay, so let's see what this would equal. 1 minus, so 10x. I mean, we have the 10x on the left-hand side, so I don't know. Okay, so this is, we certainly don't want those negatives there, right? Okay, I'm going to try this. 1 over 10x minus 1. Why am I doing that? To be honest with you, I'm not sure yet. I'm just trying, and that's the key thing with these identities, you know, especially if you're doing it on tests. You got to just keep trying, just don't get stuck. You might get stuck. So, you know, it happens. You probably won't be able to solve all of them. If you do, you're certainly better than I am. Okay. Well, 1 minus 10x. I don't know if this is going to work or not, but notice again. So I can find a common denominator, right? Like this. Now, why I'm doing that is because now this and this will cancel because they're just factors, and then this 10x is going to come up on top. And now I don't know if that helps me, so 10x. Okay, so the left-hand side equals this. Well, clearly that doesn't look like that. What should we do now? Well, I got to make it look like the left-hand side. You know what I'm going to do? I'm going to try to do a trick. I'm going to try to multiply both sides here. 10x. Okay, basically by 1, right? 1 plus 10x. Again, you might say, why are you doing this? Well, because I'm trying to... Okay, so now you'll notice that this and this, they're equal, right? And what if I bring this, right? Because it's in the numerator on top there, but just by fractions, right? I can bring it here into the denominator, so it looks like this. It's going to be 1 plus 10x. The reason why I'm doing that is because I want to see if I can get that cotangent there. So 1 plus 10x all over 10x. That's the same thing as the thing above. So that's where my 10x has gone. That's just by fractions. And now, hey, wait a minute. Okay, that's actually going to work. 1 plus 10x all over. Now notice this into this. That's just cotangent. cotangent x, and then this into this, well, that's just cancel, so that's going to be 1. Is that what it was? Hey, that's what it was. Okay, so there you have it. Sorry, I'm going to zoom out here, so hopefully you can still see it. Yeah, so that's left-hand side equals right-hand side, right? Well, you can just swap the numerator, the 1 plus cotangent x, and it looks identical. So that's another one that we did. This one was actually hard, because you have to kind of think of this trick right here. Okay, so again, that's just taking these tools and trying them over and over. Again, I think I just got lucky there. Okay, hopefully this one's better. I like these. Okay, so let's... the reason why I like something like this is because it right away just, you know, you can think of using compound angles to simplify. So like if you take this, you know, you have that pi over 4 plus x, right, which is compound. Notice on the right hand side I have just cos x. So I'm right away going to just use compound formulas here. So I'm going to use this right here. So this is for the sine, right? Don't try to use that, because that's the subtraction and then the addition. Notice I'm kind of making you think that I know all of this, but I don't. That's why I'm just copying it, because I don't always remember it. But I do notice that here's the plus, right? So plus and plus. So I'm going to use this. Okay, so that's the first one. So that's going to be sine of pi over 4 and then cos of x plus cos of pi over 4 and sine of x. That's the first one. And then this one now, so with the subtraction, so what is that going to be? That's going to be sine of pi over 4, right? Cos of x minus cos of pi over 4 and sine of x. And now the whole thing is divided by the square root of 2 there. So that square root of 2 probably is going to cancel in some way. So let's see. Okay, well, this and this will cancel because they're identical and it's a subtraction. So that's gone. So all I have left is sine pi over 4. And notice, so I have 2 of them. So this is 2 sine pi over 4 cos x, right? All over that square root of 2. Well, I know what this is, right? This is just our, pi over 4. So that's going to be square root of 2 over 2, right? Times 2. Cos of x, so that cancels. And this cancels. And you have cos of x. So this just equals cos of x. Was that what it was? Yes. Okay. So that's the right-hand side. So that's another trig identity that we have. Let's see if we can knock off this last one. Hopefully this one isn't that bad. Okay, so here's the thing. You know, you hopefully will, you know, once you see enough of these, like if I see a subtraction, right, and then I see these, which are the same, so I know that it's to the 4. Like I right away think of difference of squares. I don't, it's just ingrained in me. And if you look at these often enough, you should be able to see that. So like here, like this is what I would do. This is actually an identity itself, which equals to 1, right? And then you have, so the difference of squares, so this is cos squared minus sine squared theta. So notice, so this is gone because that's equal to 1. And this right here is cos 2 theta. That's what it is. That's from the double angle. Where is it here? Yeah, here. Notice, that's what that is. And that's the last identity that we had. So this one was much simpler. So long as you could, you know, imagine the difference of squares there. All right. Okay, so that's 5 additional examples. I'm sure you're going to be, dealt quite a few of them that you're going to have to solve. I know this is one of the chapters as you're learning, compound formulas, the double angle formulas. You start manipulating those and it gets into more trig identities like this. Okay. So hopefully, this just gives you another practice run, and you watching me maybe will give you some more little tips of things to do. So again, I hope that the video helps at least one person. If it does, okay, then it's done its job. All right, thanks for watching. Okay, take care everybody. Happy studying.